Good morning, everybody. How are we doing? Good, good. Thank you, everybody, for that incredibly warm welcome. I'm delighted to be here on the API Platform Conf stage. Sorry, a little bit closer to the mic. Delighted to be here on the API Platform Conf stage, not just because this is my first time at the conference, but there was, in fact, a very real chance on Wednesday that I wasn't going to make it here at all due to first a tree on the train line, followed by a wheelchair on the train line, followed by a trespasser on the train line, finally followed by a fairly severe technical issue with the Eurostar. But I made it, and I'm very happy to be here today to share with you a little bit more about deploying API Platform on Laravel Cloud. So just a little bit about me. My name is Joe Dixon, and I am from the UK. I've been using PHP for close on 15 years now, and I started with Expression Engine. And happened to be, my journey to Laravel was because I was attending an Expression Engine conference, and at the conference somebody spoke about this new framework on the block called Laravel, and I went away and tried it and was kind of hooked ever since. So I took Laravel to the company I was working with at the time. I then co-founded a small startup, and we built everything on Laravel there. And to complete that journey, I now work at Laravel. So I've been there for the past 3.5 years, where I first worked on Laravel Vapor, and was fortunate enough to be one of the kind of founding members of the Laravel Cloud team. Okay, so let's kick off. We're going to do a little bit of 15 minutes-ish of slides, talking a little bit about what Laravel Cloud is and how it works, and then we're going to go into a demo. So first of all, what is Laravel Cloud? Well, Cloud is a fully managed platform. We strive to take the pain out of provisioning, managing, and scaling the infrastructure required to run even the most demanding of workloads. We're really built from the ground up for scale. And we have all of the resources required to run alongside your Laravel application. So things like databases, we have MySQL and Postgres offerings, we have Redis caches, we have object storage, we have soon to have WebSockets, all fully managed and baked into the platform. And it's possible for you to deploy your application in just a few seconds. And that was really one of our guiding light metrics as we were building out the cloud platform. I sat down, before we even broke ground on Laravel Cloud, I sat down with Taylor Otwell, the creator of Laravel, and we talked about this hypothetical platform which would become Laravel Cloud. And I said to Taylor, what is your number? And his answer was 1 minute or less. But of course, you need to know what the question actually meant. And what I meant by that number is, what is an acceptable elapsed time from somebody logging into our platform to clicking or to connecting their source control to deploying their application, having it accessible and visible somewhere in a browser? And his answer was 1 minute or less. So our North Star when we built out Laravel Cloud was 60 seconds from sign up to ship. There were some pretty hefty decisions to make along the way. We, first of all, needed to decide which hyperscaler that we would use. We were always going to build on a cloud platform, particularly for this first iteration of Laravel Cloud. But what would we use? And actually, this was probably the simplest question of all that we've had to answer in the last 18 months or so. Because a lot of our partners that we're working with and a lot of our customers that we're working with are all on AWS, and it's the platform that we are all the most familiar with. And so it was always going to be AWS that we opted for. But then it got a little bit more difficult. Which tech stack within AWS would we want to deploy on? Our initial thought was, well, let's use Lambda because we've been running Vapor since 2019. We have good experience of running PHP applications on Lambda, and it works really, really well. But there are some limitations with Lambda, things like 6 megabyte file upload limit and 30-second execution times for responses to have to go back to the client. And these were all things that we kind of felt we didn't want our users to have to worry about. We wanted them to be able to bring their applications to cloud and everything just work. And so we actually ended up landing on Kubernetes as our kind of technology stack that powers most of Laravel Cloud. So those were some kind of high-level decisions to be made. Then we had to get into the weeds of how we would actually structure this project. And one thing that many people may not have even realized is that you can't run a platform at the scale of Laravel Cloud on a single AWS account because we just bump into way too many limits. Things like number of S3 buckets, even number of CPU cores were allowed in a single AWS account, number of RDS instances. The list goes on. It's just not possible to have everything in a single account. So we had to come up with a really good account sharding strategy. And ours looks a little bit like this. So I mentioned that we used Kubernetes, but we actually use AWS Managed Kubernetes, which is a service called EKS. And each one of our EKS clusters is in a dedicated AWS account. We have our networking in a dedicated AWS account, which may sound strange, but I'll talk a little bit more about that in a minute. Our internal tooling, our web app, our build service, and our logging service are all in a dedicated AWS account. And then you need to multiply this out across all of the regions that we're in. And so what that ends up looking like is that we don't provision Laravel Cloud services in a single AWS account, not even 10 AWS accounts. To date, we're running in close to 200 AWS accounts, which takes quite some orchestration. So jumping a level deeper into the stack, we're going to talk a little bit about networking. And I mentioned that our networking is all in a single AWS account. You can see the networking section at the top of the diagram there. What we're able to do is use a technology called RAM sharing. So we can say we have a VPC in our networking AWS account, and we can share that VPC with other AWS accounts. Namely, in this case, one for each of the AWS accounts containing our EKS clusters. And then for the remaining pieces of networking, we use combinations of transit gateways and VPC peering to make sure that all of our services can talk together in the most efficient way. Again, it's very, very complex and took some planning at the beginning to make sure that we got this right and didn't back ourselves into any corners. Jumping a level deeper, let's talk a little bit about how we route requests from an end user to a workload running somewhere in this sprawling infrastructure. Well, we made a decision relatively early on that we would partner with Cloudflare to handle our edge networking for us. They take care of all of the denial of service attacks. Caching, we have ability to create rules to be able to kind of have that edge network behave in the way that makes sense for us and our users. So what happens here is a request comes in from a user and it hits Cloudflare's network. Then a domain or a host name is created within Cloudflare, which has an origin of one of our EKS clusters. But Cloudflare needs to get that request to that EKS cluster somehow. And what we use for that is a service called Cloudflare Tunnels, which basically allows us to establish a secure tunnel between our infrastructure and Cloudflare itself. So we have a Cloudflare agent running in each of our EKS clusters, which will establish that connection for us. So that gets the request from the user through Cloudflare into the relevant EKS cluster. But then from there, we need to direct it to the pod running the customer's workload. And so each cluster then has its own ingress, which receives the request and forwards it to the correct pod. And that pod will be running either Nginx or FrankenPHP and Caddy, depending on the flavor of Laravel that the customer is using. And what's interesting here is that we actually didn't start this way. When we first started working on Laravel Cloud, we had our own internal routing layer that we had built from the ground up. It was a single entry point into cloud, which we would then do the distribution of sending the traffic to the relevant cluster. But we actually just had a seemingly simple problem to solve that we couldn't figure out how to terminate the MTLS certificate between Cloudflare and our internal routing layer. So we jumped on a call with Cloudflare, and that was when the engineer on the call muttered the words, Cloudflare Tunnels. And we actually knew about Cloudflare Tunnels as a product, but we just weren't aware that it could run at the scale that we would need it to. And so in that one 10-minute conversation, we were able to rip out that whole infrastructure layer that we no longer have to support, which reduces the overhead and the complexity for us, but also improves our reliability because we are leveraging a product which exists specifically for this use case. And that was a really nice side effect of our partnership with Cloudflare. Okay, so we have the request coming in, routed to the customer's workload, but how does that workload get on a cluster in the first place? Well, there's a number of moving parts here. We have our web application, which we'll see in a demonstration in a minute. And the web application has the ability for the customer to decide how they want their application and their environment and their compute to be structured. Once they're happy with that, they can click the deploy button in the UI. And what happens when they click deploy is that a job gets pushed onto an SQS queue. On the other side of that queue, we have a Go-based operator, which is polling for jobs on that queue. And that operator is basically in charge of a layer of orchestration above Kubernetes to make that environment or that application compute look like how we need it to look. And what it does is it takes that job, it takes the payload from the job, and it calls an internal API to pull in all the details about that environment. The first thing it does is sends that off to our build service to turn that into a deployment artifact. So in that case, we'll take all of the source control repository that gets cloned down. We run any commands that the customer wants to run as part of their build, and it will basically turn that into an artifact. In our case, a Docker image, which gets dumped into an ECR repository. The app operator then knows that this has been done successfully, so it drops a job back on the queue, and the web app says, great, the build is finished, let's go ahead and deploy it. It drops a job back on the queue to say, go ahead and deploy it. The app operator will then pick that job up. It will basically turn all that data into a custom resource and apply it to the Kubernetes API. And then Kubernetes takes over and we get all of that good stuff for free, things like zero downtime deployments and all that good stuff. But the app operator does way more than that as well. It's actually in a continual reconcile loop because we want to make sure that what the customer sees in the UI when they're interfacing with their application actually is a fair reflection of what's happening within Kubernetes itself. And so periodically we are polling our internal database to say, give me the state of the world right now, tell me what this cluster should look like. And the operator will then compare that with what's actually happening on Kubernetes and make sure that those two things, there's no drift between the two. And we found this to be an incredibly powerful pattern for us. This started just for customer workloads, so running application compute, but subsequently we have added a MySQL offering which follows a very similar pattern. We're adding Valkey very, very soon, and we have Reverb, which is Laravel's kind of WebSockets package. We're going to have a managed Reverb offering, and all of those follow this very similar pattern. So in summary, we built all this in just less than a year. We broke ground on Laravel Cloud in, I think, March of 2024, and we launched in February of 2025. And in the 6 short months since then, we've already processed over 1 million deployments. And just to summarize and to wrap up where we started this conversation, with our North Star metrics of 60 seconds from sign up to ship, yeah, we did achieve that. It's slightly variable depending on what you're doing during your deployment, but in the standard case with a fairly simple deployment, we sometimes see deployments of anywhere between 30 and 60 seconds. But let's jump in and take a look. Okay, so this is the cloud user interface, and I have a brand new account set up specifically for this demo for API platform. I even put Webby up here on the left so that, for a bit of context. Okay, so we have a completely empty account, and we're going to go ahead and create a new application. Hopefully the internet gods are with me on the stage. Okay, here we are. So we have the ability here to see that we can import an existing repository. I have 2 GitHub organizations created here, and I can choose to import an existing repository if I have one that I want to pull in. But in this case, I don't. I want to start my brand new API project. So I'm going to go ahead and use a template. And in here, I have several options. These are basically all of the Laravel starter kits. We have an empty Laravel application, we have our React, our Vue, and our Livewire starter kits. So I'm just going to go ahead and start with an empty Laravel application. And I can choose here the GitHub organization which I wish for this to be created in. So what's going to happen behind the scenes is when I create this project, it's going to go ahead and deploy an empty Laravel application for me, but it's also going to stub out my GitHub repository and push the files there for me. So everything I need from the starting place is done for me. I'm going to give the repository a name, in which case I'm going to call this my API. Going to keep it private. Going to keep the application name in sync with the repository name, and let's choose a region which is a little closer to home. And I'm going to create that application. And once this creates, we are dropped. I'm going to just drop that down a little bit. We are dropped into a screen which we term affectionately internally as our environment canvas. It's basically a place where we can see everything about how our application compute is structured. We can see everything about details about our edge network, any domains which we have attached to our environment. So here we automatically get a cloud domain. This is the thing which facilitates that want to be able to see my site within 60 seconds of hitting the deploy button. We have that domain ready to go for customers. But we can also attach custom domains here when the time comes that we want to give this and share it to the world. We have details about our app cluster. So this is the actual compute which will run our application. And I can click in and show you some more details here. I can choose the compute size which I wish to run. I can choose any background processes which I wish to run. So if I'm running, for instance, processing queue jobs, I can set my queue commands in here with a really nice, simple user interface. I can enable Laravel Scheduler just with a toggle switch. And then something really interesting is this hibernation option. If I toggle this, I can tell my application or my my compute environment that I wish to hibernate my application. And what that means is, if I don't receive any HTTP requests within a 5-minute window, I actually want you to spin down that compute completely, and so I'm no longer charged for it for the time that it's turned off. And then as soon as we receive another HTTP request, we will automatically wake that environment back up. There's a slight cold start penalty for doing so, but we'll wake that environment back up, and so you're only charged for the times that you're actually running any compute. We have auto-scaling options in here, so I can see here that I can scale between 1 and 10 replicas, and I can choose what my CPU and memory threshold should be for when my application should scale up and down. And of course, I can choose Octane as a runtime. So for those of you not aware, Octane is a package for Laravel which basically allows us, when we install it, it allows us to run our application in a slightly different way. And what that means is, rather than booting the application for every single request that comes in, we boot the application once, and it stays in memory to serve subsequent requests. And so with just a toggle switch, we can enable that in Laravel Cloud, and that will basically, under the hood, switch us out from Nginx and PHP FPM runtime to FrankenPHP, to Caddy and FrankenPHP. So I'm going to enable that now, and I'm going to hit save. Okay. So you can see at the bottom here that we've also automatically triggered a deployment when we created this application. So that deployment has been successful. We've got the green check mark, so I should now be able to just click the visit button here. And here we are on our Laravel 12 splash screen. So you can see that our application has now been deployed and is accessible in the browser, ready for us to start working on. And what's more than that, if I jump into Cloud again and I click on my GitHub repository link, my new repository, my API, has been created with all of my application files stubbed out with an initial commit by Laravel Cloud. So I'm going to go ahead and grab this, and we're going to jump into my terminal, and we're going to clone this repository. Okay. Is that big enough, by the way? Can everybody see that? Let's bump it up a little bit. Okay, so we have a brand new application set up and now accessible locally. I know that I want this to be the start of my API, so I'm going to actually install a few things to get this up and running. And I have a snippet there, so I didn't have to type all that out. So basically, for the purposes of this demo, I want to demonstrate API Platform and Laravel Cloud, so I'm installing API Platform / Laravel. I also want to demonstrate some nice caching options that we have. So I'm going to install API Platform / HTTP cache. I need Octane because I just enabled it in the environment. I'm doing what I probably shouldn't do. I'm pulling in Faker as a production dependency. And I am installing API Platform, which will basically publish the configuration file and all of the assets which allow me to access my Swagger docs. So let's install that now. And yes, we will move that to a production dependency. And that's everything installed. So let's, for better or worse, we just had a nice AI talk. Let's open up Cursor and have a look at what's happened there. Don't want terminal, I do want this. Okay, so you can see here that in my source control panel, our dependencies have all indeed been updated, our lock file's been updated, and all of our assets and configuration has been published. So let's go ahead and whip these changes up. Good, internet is working. Okay, so if I jump back to the cloud interface now, where are we here? You'll see that we have processed that webhook, we have push to deploy enabled, so we're automatically triggering a new deployment of our application. That's going to take a minute or so, so I want to talk about another couple of things while that's deploying. I know for a fact for the next part of the demonstration, I'm going to need a database. So again, from my environment canvas here, I can add a database to my running application. So I can click up here, add resource, and I can select database. And I can, inline here, can create a brand new database and attach it to my environment. So I'm just going to stick with the defaults, but I'm going to change to serverless Postgres, and going to stick with Frankfurt so that we don't have latency between our app and our database. I have full control over how I want to configure this database, but I'm just going to choose for now, for speed, one of the pre-configured options that we have in the UI here, and I'm going to go ahead and click on Create Database. And in just a few short seconds, we should see that our database is completed and provisioned, and that's now available for us to use within our application. And just to prove that, and to show, save that first. To prove that that works and show some of the legwork that Cloud does for us, I'm going to jump into the settings, and I'm going to scroll down to our environment variables section. So you can see here that I've not added any custom environment variables. The only thing that gets added here is our app key. But what Cloud is doing on our behalf is injecting a bunch of environment variables because it knows a bunch of details about how we want our application configured based on the things that we've configured on that environment canvas. And one of those you can see is it's automatically injected here our database credentials so that the next time that we deploy, we will have connectivity directly to our database. Okay, so if we jump back to deployments, with a bit of luck, our second deployment has now gone out with our WIP commit. So if I visit the app now, still get our splash screen, but if I hit /API, we have our Swagger documentation available for us to play with. But of course, there's nothing in there yet because I haven't told API Platform what I want to expose publicly at this point. So let's go and make that happen. But to do that, I want to come up with a hypothetical scenario. We have our production environment here. Well, let's assume that this is our production environment. So we may have this scaled up a little bit more with bigger instances than we would do in other environments. But we probably shouldn't be making changes on the fly directly to production, directly to our main branch. So what if we want a staging environment to go along with our production environment? Well, we tried to make that really easy too. If I click this ellipsis up here and click the replicate option, you can see that I have a way to replicate an existing environment. And we get some affordances here to allow us to choose exactly how that should happen. So if I had more than one environment, I can choose which one I want to replicate. I just have main at the moment, so we'll stick with that. Now I can choose the branch I wish to connect, but I only have one branch at the moment. I only have the main branch, and I probably don't want my staging environment running on the main branch at this point. So let's jump back over into Cursor, and let's open up the terminal. And we will check out a new branch called develop. Okay, I'm actually going to do a little bit of work here, so as I want to avoid an extra deployment for the purposes of being on the stage. So let's go ahead and push some changes at the same time as creating this new branch. So Laravel ships with a user model, an eloquent model that represents our users in our database. And the one thing that I can do here to expose these is annotate it with the API resource from API Platform. And that's all I have to do to now create these routes that will accept allow me to interface with my users from my API and generate the documentation for me. That's all I need to do there. But for the purposes of the demonstration, let's also make changes to our database seeder. So in our seeder, I'm going to go ahead and create 100 new users. And I'm just going to get rid of this because I don't super care about having a test user at this point. And that's all the changes I want to make. So let's jump back into source control, and we'll whip these changes up too, and we will publish a new branch. And if I jump back to Cloud quickly enough and open the panel here, you should see, hopefully, that, there we go, our develop branch appears for us in real time there as soon as we push it up. So I can go ahead and create this staging environment from my develop branch. And I can give this a name, and I can choose a color that represents it, so it's obvious to me what type of environment, which environment we're working in at any given time. But then things start to get a little more interesting because I can choose the replication options which I wish to use to create this environment. So I can choose how I want my compute to be replicated. Now imagine, I mentioned earlier that in our production environment we may be running bigger instance sizes and we may be scaling up between, anywhere between 1 and 10 replicas. And perhaps we don't need that exact same thing in our staging environment. So we can choose to do that if we wanted to. We can choose to replicate and downsize, so we still have the same scaling options, but we downsize the amount of compute and we enable hibernation by default. Or we can just choose to have a single app cluster, no horizontal scaling configured, and again, with the smallest size of compute and hibernation enabled by default. And that's what I want in this case. Databases are also interesting because we have this resource. Do we want to create a separate database for each one of our environments? Now, I could make a good argument that between production and staging, that maybe we do, but for the purposes of this demonstration, let's assume that we want to be able to share that database between multiple environments. So I have options here as well. I can choose to use the exact same database on that database cluster that I created. this case, I think, is a really bad idea because we don't want to run migrations in our staging environment which impact our production environment. But maybe I could get on board with creating a new database on our existing database cluster. So we end up with one for our production environment and one for our staging environment on the same database cluster, but with a separate database for each. That's the option I'm going to choose here. But I could equally choose no database, and then back from that environment canvas, we could go and choose how we want to add that database. Similar options if I was using caches, object storage, and WebSockets. But I can go ahead and save those replication options and click on Replicate Environment. And here we are, dropped back on our canvas again. So you can see that we're updating that database cluster to add our new database to it, but we have our new environment created here with our Flex, 1 CPU, half a gig of RAM, and hibernation enabled automatically after 5 minutes. Now before I deploy this, I want to drop into settings, and there are actually a couple of things that I want to change. The first thing I want to do is drop in and enable in my staging environment. I want to have debugging set to true. If I could type on stage and save that. And in my deployment commands, once that's saved, I want to go ahead and change this to also seed the database. Okay, so we're going to save, and this time we're going to save and deploy. Okay, while that's deploying, I want to show you another couple of things in the UI. So we've seen the environment canvas, we've seen now the deployments tab. We haven't seen this in too much detail, but this is where it will show you the output of how the application is being built and the steps it's going through to deploy it. What we also have in here is the option to run one-off commands. So if I wanted to go on a one-off basis, nuke my database and remigrate it and reseed the database, I can do that from here. If I had some custom commands where I want to sync data between different data sources, whatever that might be, I can do that directly from this panel. Of course, I have access to logs because I need to be able to see how my application is performing and what bottlenecks we might be running into. So I have here the ability to search my application logs and my access logs. And I can search the logs here too and choose the time window which I wish to search between. I also have the ability to look at some metrics, so I can see how much traffic my application is dealing with. I can see at any given time how much CPU and memory my application is using. And really nicely here I can see my replica count. So if I am running in a, with horizontal scaling enabled, I can see at any given time what level I'm running at between the bounds that I've set within the UI. Okay, so that has now deployed successfully. But you can see now that we are hibernating. So as soon as we've deployed this one with hibernation enabled, we hibernate by default. If I jump back to environment and click visit, we'll see that we get this cold start penalty, which can be somewhere between 5 to 10 seconds for the environment to wake up, just for that first HTTP request after hibernation was enabled. But there we are with our splash screen again. And if I go to /API/users now, we can see that our user model, which we annotated with the API resource, is now accessible to us within our Swagger documentation. And we can see the data that I've seeded is here and accessible within the UI. Okay. I also wanted to show something else. If we look here in the network tab, and we refresh the page here, we look at the response headers, you'll see here that we are not leveraging any CDN caching here. So we have this partnership with Cloudflare, which we can use and should use to help take the load off our origin resources. But we're not doing anything because we're telling everything here should be private, which tells our CDN that it shouldn't cache any of those details. And just to confirm that, you can see that the Cloudflare cache status here is set to bypass. And just to prove that's not a one-off, i.e. a miss from the first request, we're seeing this every time we refresh the page. Okay, so I think we can do a little bit better than that. And for that, to demonstrate that, I want to imagine another scenario where we now have our production and staging environments, but what if we're working in a big team and we're working continually on lots of different projects at the same time, and we want to test out our pull requests in isolation from any of our kind of production or staging environments? Well, Cloud gives us a really nice some really nice options for doing this as well. So if I jump at the top level, application level, and I click into settings, and I have this preview environment section, which allows us to create automations, and those automations will create environments for us automatically. So if I click in here to add a new automation, let's imagine as part of our flow we want to have a QA testing step. So we'll call this automation name Q testing. And at this point I can choose, again, similar to the manual replication, we can choose how we want our environment to be replicated. So in this case I want to replicate staging. And now I can choose the conditions as to under which this environment should be created, or the conditions in which it should be triggered to create the new environment. And broadly speaking, I have two options. I can choose it on new pull request, or I can choose to do it on a new branch being created. Now, I'm interested in doing this for new pull requests, so I'm going to keep this option selected, and I have to just choose my target branch. So this should only be triggered at the point when the new pull request is opened that targets the develop branch. And I have further control over that as well. So I can say, I may not want every pull request that gets opened against develop to trigger this automation. I may want a little bit more control or some business rules internally to say when we should create a new one. So I have this option to filter the branch name on the branch name, the source branch name, starting with, ending with, containing or matching the regex of the given string. So I'm going to choose this default option here. So now we're saying anytime a new pull request is opened that targets the develop branch, where the source branch starts with feet and a /, only under those conditions should this automation be triggered. I get very similar replication options which I had previously, so I can choose how I want my compute to be replicated, how I want to use my database, caches, object storage, WebSockets. I have the ability to inject any custom environment variables I wish here, so if in these test environments I'm connecting to a completely different mail provider, for instance, I can choose to add those in here and they'll be created or injected automatically for me when this new environment is created. I can also choose how I want this environment to be created. So do I want it to be automatically deployed when this automation is triggered? Or do I want to have a little bit more control over it, and so I can choose when I start to get charged for those for that new compute getting provisioned. And similarly, once this pull request goes stale, it's merged or closed, what do I want to do with that environment? And I can have the option to have cloud clean up those resources for me. And I can indeed have initial deploy commands. So again, I'm going to choose migrate and pass the seed option. And as another nice layer of security we have here, we can lock these preview environments down, because maybe we want our production environment accessible to the world, but maybe we don't want our staging and testing environments accessible. So we can very easily put basic auth in front of this too, by just adding a password in here. And we can create that automation. So what you can see here is that we have our QA testing automation created, and what should be obvious is we can have multiple different automations. So if we need to create environments under different circumstances, we can do that really easily from here. But let's check this out and see what it actually looks like in practice. So this time, let's check out a new branch called feet caching. Let's close that for a sec. And this time, we'll jump into the API platform docs, and we will, the config, and we'll look at the cache settings. So I have to big shout out to Antoine for this, because I had some problems getting this wired up while I was preparing for the talk, and he pushed some changes very, very quickly for me to get this up and running. So we're going to uncomment this section here. We are going to, probably don't want to do this in practice, but for the purposes of this demo, let's set everything to be publicly true, and we'll set a max age of 600 seconds, and we will just, again, whip these changes up and publish this branch. If I go now back to GitHub, we need to open a pull request. So let's refresh our repositories, open my API repository, and let's open a pull request for this branch. So remember, this should only trigger when the target branch is set to develop, and the source branch must contain feet/caching. So we'll do adds HTTP caching, and we'll create a new pull request. And in just a few seconds, we should see something happen on this pull request. There we go. We have a comment added by Laravel Cloud to tell us that the new environment has been created for us, and it gives us a link directly to that new environment. It tells us that it's automatically deploying, because that's the configuration settings that we chose when we created that automation. And it's giving us the details of what should happen, or the details that we've chosen of what should happen to that environment once the pull request is merged or closed. And it gives us a link to the settings to change that if we want to for any reason. let's go ahead and open this link. And indeed, we can see that we're dropped again on our environment canvas, and we have our application automatically deploying for us. Now, while that's deploying, I wanted to show one more thing. In the interest of us talking about caching, let's take a look a little bit more about the options we have in our Edge network. So if I open the Edge network panel here, you can see that I have some control over how I interact with my cache, the Edge cache in this case. So I can choose, and this is enabled by default, to automatically purge the cache on every deployment, because maybe we're building new assets with the same names and we want those to be refreshed on deployment. We can also manually do that with the manual purge cache button. And if we're debugging something, because debugging caching issues is always a fun one, we can bypass the cache entirely temporarily just to see what's happening. We also have some response rules that we can change, so we can eject headers directly without us having to do it at the application level, directly from the Cloud UI. And we have ability to do firewall type options, so things like rate limiting. We can choose to challenge or throttle or ban users when they hit certain rate limit thresholds. And if we're really in trouble, if we're really getting a denial of service attack, we can come in here and raise the alarm by clicking the or toggling the under attack mode option. And that will automatically pop up a JS challenge for any user accessing the site, and hopefully helps mitigate that issue that's going on. Okay, let's reset this. Our application has deployed, so let's go ahead and visit. So there's our basic auth. So I can just type in the credentials there. We're going to, again, have a slight cold start penalty because we're automatically hibernating, but when our application comes to life, we will automatically go to api/users.json ld. And if we look in the network tab now, refreshing that page, look at our response headers, you can see that our cache control headers are now being set correctly. And just by doing that, with the simple configuration changes within API Platform itself, we now get a cache hit from Cloudflare. And so we're taking a load of burden off our origin servers and putting a load of the work onto our Edge cache instead, which is always a huge bonus. Obviously, there's levels to this. We can't do this for every endpoint necessarily. Some of that data needs to be a little bit more dynamic, but there are really good use cases for doing that. Okay. That's just about everything I had today, if I can get back to my slides. Just to summarize, I think API Platform is an incredible tool for allowing us to build APIs and have all that documentation and everything available to us out of the gate in all of those different formats that are available to us. Hopefully I've shown today that with something like Laravel Cloud, we can kind of streamline and automate some of those processes and make those two services dovetail really nicely together. Thank you.